Yeah, good morning, everybody. We will be actually two people in this session, so let's tell a little bit about us. So I'm Radovan Bast, University of Tromsø. Previously chemist, but since, I don't know, a decade now, almost, really focusing on computing. I really like helping research to do computing better, helping out with programming. I'm more the software person. And I'm really looking forward to go through the rest of today with my colleague Jörn. Maybe you can also say two sentences.
Hello, my name is Jörn. I also work for the University of Tromsø, like down the hall from Radovan, and my background is chemistry / biochemistry. Biochemistry, and then later now I turned into more like computational biology, bioinformatics, something like that.
And we understand research. We don't know everything. It's not a problem. We are all here to learn. We really like helping and supporting research. We will be doing the sessions together, so we will co-teach here. The goal is that what we want to avoid is, I don't want to do it as a monologue. We will have hopefully a dialogue, not only with Jörn, but also with all of us. We are not that many, but still I understand this is being, recorded, so it's good if you have your video and audio off, but you can interact through the collaborative document. And maybe somebody can help me post again the link to it for those who joined later. And we will be both watching it, and Jörn will help me. So the idea of two people teaching is that we can have a conversation. If I go too fast, Jörn can slow me down, can ask clarifying questions. Also, we can help each other watching this collaborative document. So far, we have 3 really good questions, and hopefully we get many, many more questions. So please keep them coming. No questions is stupid. The simple questions are often the best questions, and we will try to solve them. Also, you might notice that my screen share is a bit different. So what I try to do is that my screen share is more like a portrait, narrow, not landscape. And down here is my terminal, and down here is the history of my commands. And the idea is that you can, on the other half of your screen, you can then also do some work. And in these sessions, we will do some exercises. We will first introduce what we are about to do, so you can still prepare, but I encourage you to prepare your terminal. You will need it in 10-15 minutes. And then if you like, you can try some of these commands as well. And I encourage you to try it out because I think they are really, really important. So on one half of the screen, I will share my terminal and we will see the collaborative document or the material. And on the other half of your screen, I encourage you to open up a terminal. And also, please keep questions and comments coming through the document. The more questions we get, the better the session will be. And to give you an overview of what to expect, here you can already anticipate, we will talk about 2 really important topics that everybody has to decide. Everybody has to choose this. Everybody is expected to choose how many cores and how much memory. But this is often the thing that is not well explained how to do it. It depends, but we will show you techniques that we use to find out, so how much memory should I use, how many cores should I use? And so we are here in the overview in our course, and what we will do is we will loosely follow 2 sections that we have in our documentation. So everything that we will show is in our documentation. For instance, we will start with the question how to choose the right amount of memory. And if you follow this link, you will come to this page, and this page shows, it motivates why it matters, why we need to do it, and the many different techniques on how to find out. And we will show you some of them, and you can also practice some of them. I can also show you how I find it normally when I don't remember what it is. So on the documentation page, if you go to the overview page, we have these cards here, and one of them says job types and scripts. And if I click on the job types and scripts, then you can already see the links that I frequently visit, but these are the two that we will talk about. And I will also now, just to make it easier for everybody, I will let's start with the question about memory, because this is, everybody has to answer this. And I will copy this into the document. So we are here currently. So that at every point you know where we are. But I will maybe not start with the page. I will start with a demonstration. So at this point, you don't have to do anything. You can watch me, and later you will get the chance to also practice. So I will go to choosing memory. This is an example. You will see a similar example in the exercise. And the example is, I think, very typical. Let's imagine I'm starting my PhD, or I'm starting my postdoc, and now I inherited from my colleague. Here is a binary. I didn't write it. I didn't compile it. It comes from somewhere. Maybe I loaded it, module load. So somebody else has created it, not me. And I inherited this run script also from somebody else. Let's look at the run script. In the run script, I run this mysterious binary. And now we don't need to focus on all of these. Let's focus on this one here. So I'm on Saga cluster. So this is still a demonstration. And now I need to set something in here. I got this from my colleague on 1.5. So this, I'm telling Slurm that I need 1.5 gigabyte memory. And so I don't know, is that enough or not? Should I ask for more? Maybe that's fine.
Radovan, but why should I care? I mean, if it runs.
That's a good question. Why should you care? So why is the question like why do we need the line at all there?
Like no. I mean, I got this run script. You try it out. It runs.
Mm-hmm. Actually, here let me try it whether it runs, because I think it will actually not run. And then we can think about what we do next. So I will submit it. And let's see whether it's still running. It already finished, so that's not a very good sign. It finished, it was very quick. And I have here output from Slurm. Let's look at it. And we'll make this a bit larger. So there is a lot going on, but the thing that is problematic, there isn't somewhere error, so blah blah blah, error detected. So what is the that's shortcut that I don't know why there is not a nice error message, but it's not something we created. So it means out of memory. So here the memory was not enough. But now I come back to a question. So this was not enough. So how much should I take? 10 times as much?
Yeah. I would have also 10 times is a good number to start with.
Yeah, and now I can try it. Should I first try it whether it works, and then we can discuss why it matters and why do we have this session at all? So let's submit and let's see whether we are more fortunate this time. And it doesn't stop immediately. That's already good.
Did you choose one which takes not 2 hours? Or?
No, this is so the colleague who I inherited from told me that this should take around a minute, maybe less. I think it takes less. I think maybe 40 seconds. It
Like
gives
I
us.
personally, I have run into this problem a couple of times that like you want to run something and then it takes you quite some time to figure out how much memory. And I mean, the
Yeah,
easiest way is like just ask for a lot. And
yeah.
if it
That's what we
doesn't
did
give
here.
enough, yeah.
So a lot helps a lot. And now if I look at the Slurm output, I think things look better. There is no error.
Mhm.
It completed. Let's not focus here too much on. There is something here, information about memory. So it tells me that I allocated 14 gigabyte. Is that right? Yeah, approximately.
We asked for 15, but it's not far off at least.
Yeah, and that's gigabyte, and it tells me that I used less than that, a lot less than that. So why is it? Now I could be happy. Well, it works, so I will leave it like that. What is a possible problem with that? Why? I should probably ask for less than 15. And why is that?
I would say, I mean, of course, since we run the hardware, we of course want like to have it used as efficiently as possible. And if everyone asks for way too much, that means there's an unused part. And especially in your case, where you, if I read it correctly, only ask for one core, CPU core, and then you basically book the whole memory unnecessarily. That means that other people can't run on the same node. Like on Saga, we share the nodes, so.
Yeah, that's the point. We are on Saga. There can be actually more people on one node. Each node has, I think, 40 cores. But each core has, I don't know, I don't remember, but if I can show you how we can find out.
Yeah, because that's something which is always easy, like good to know how to find out these things.
Yeah, so here on our documentation page, on top we have overview of the hardware, but also overview over the different clusters. So if I go to Saga, and I will zoom in a little bit. So we have, there are 200 nodes with 40 cores, and then there are some other nodes with 52 cores. And each of them has 192 gigabyte. And now if I divide 192 divided by 40, it will be roughly 5 gigabyte. But here I want one core, but 15 gigabyte. And what happens under the hood here is that Slurm knows that each core has only 5. I ask for 15. It will block 3 cores. The cores will donate their memory to me, and they will become unavailable to everybody else. And it's not only a problem for everybody else, for the other 2 people who are not running their job because they are queuing, it's also a problem for me because I will get charged for 3 cores, but I'm also only using 1.
Yeah, I mean, and we did that for the reason that the machine you use more than your share of only the cores. So you just get billed for the others as well to make it a bit more fair and to motivate efficient usage of the resources.
Yeah, there is another problem, and another problem is not only resource use and being fair to everybody else and being fair to my wallet. The other problem is that if I ask for, I don't know, 45 gigabyte, and Ule has nicely explained this, Slurm doesn't know that my job will consume a lot less. If I ask for 45 gigabyte, Slurm thinks that I will need 45 gigabyte. They may not be available at this moment, and I will be in the queue waiting and waiting and waiting until these 45 gigabyte become available somewhere. So the disadvantage for me is that I will probably be waiting in the queue for a long time. So it is good to ask not for excessive amount because you will queue less, you will pay less, and we get more signs done. But now the big question is how do I know how much should I ask for? once you know how much your memory, how much your binary consumes, I recommend to ask for like 20% more, just to be on the safe side, but not 2000% more. But how do we find out how much we consume? We have already seen that there is something in the Slurm output, but there are other ways to do that. And you in a moment, so in like 5 minutes, we will give you time so that you can try these out on your own. But I want to give you here an overview, and we can maybe pick one or two and demonstrate them here. So there is motivation here why it matters, but we talk about it. How can we find out? One not very elegant, but also okay way to find out is to log into the compute node and have a look at the processes that are running. I think I want to demonstrate it because it's a useful thing if you are unsure what is my calculation really doing on the compute node. Does it really run the way I expect it to run? Should I demonstrate it quick? I will maybe try that, but I will not ask for 45 gigabyte.
Do you want to run the binary twice? Otherwise, you only have 30 seconds.
But I maybe will manage during 30 seconds.
Okay.
Let's see. Maybe I'm quick, so I will try. And I also need to say why am I running in 30 seconds? That's important. Let's come back to that. So let me submit, and now let's see where is it running. Ooh, quick. It's running on this node. Let's SSH into it. And on the node, now I'm on the compute node, I can do top, and it shows all the different processes. But here I'm really only interested in what I do on that node. And this is the one, I still have it, 3 gigabyte. Ooh, here it says 3 gigabyte. Somewhere else I saw 6 gigabyte. So it's still running, and a few seconds later it will complete. Now it finished and disappeared. So this is another way to see not only how much memory, later we will also see that we can see how many cores I'm using on the node, how many cores I'm occupying on the node. So I will go out of this with Q, and I will go back to the login node. So this was one not very elegant way, but it's useful to know.
Well, is there a disadvantage of using top?
What is the disadvantage?
Yeah, I mean, you have to be present while it runs, but otherwise, is there a problem?
There is not really a problem. So you can log into your compute node while the job is running. I think I cannot log in anymore after the job is completed. So you have to be like present. You have to go there. It's not very useful if the job crashes immediately, because then we just don't have enough time. Also, it only gives me a current snapshot, because maybe my job consumes different amount of memory as the time goes. And depending on when I log in, it either consumes a lot or not a lot. So it can be nice to have a summary. And there are other ways to get summary of the memory. So I can look into the output, Slurm output. We have seen that. There is also something called Ceph, Slurm efficiency. If I know the job number, for instance, the last one, then I get the output like this. CPU utilized, memory utilized. This is actually a little bit weird, because we saw that it was 3 gigabyte, now it's 6 gigabyte, and I will comment on that. But it's another method. I should also say why. Yeah, go ahead.
In general, I prefer Ceph because it gives you a easy way of telling. Yeah, but currently the numbers seem a bit wrong.
Yeah, and question 4, is it possible to know how much memory was actually used? You did ask for 3, and it was 3 gigabyte. How much was actually used? Well, good question. So Ceph is telling me that I have actually used 6.12. There is another method that I want to test out. Do we have the time? Yes, we have the time. Because there is sucked and there is job stats, so many different methods. I want to show you one that I also really like. And we can compare. So in my run script, in front of whatever I do, I can put this USR bin time minus v, which looks a little bit surprising because I'm here not interested in so much in the timing, but it will also give me not only the timing, it will also give me some statistics about my binary. It will give me very detailed statistics on how much it consumed. I will try that as well. Let's submit it once more. And while we wait 35 seconds for it to complete, let me explain why did I make it 35 seconds long. Because Slurm samples the memory every 30 seconds. Which means that if your job is shorter than 30 seconds, Slurm will tell you that this didn't consume any memory. Also, if you are lucky or unlucky and the memory varies and every 30 seconds it consumes nothing and then it starts consuming a lot, it may also sample at the wrong times. It's good to know. So that it samples at 30 seconds intervals and we can be lucky or unlucky and the sampling can give us misleading information. On the other hand, the method that I just used will tell me how much it used maximum. Are we still running or are we finished? We are finished. And let's look into the last output. Oh, I will cut it. And the output is up here. So this is the statistics. There is lots of statistics, but the one that I'm interested in is this one. It's the maximum memory used by the job. And it's 3 million kilobytes, so 3000 megabytes, so 3 point something gigabyte. That's the answer to question 4. But why did I get the different answers? So this thing tells me 3 gigabytes, Slurm told me 6 gigabytes. What's the mystery there? And the mystery there is that we don't know. Since Saga got reinstalled, we have wrong memory statistics from Slurm. We don't understand yet why. So we are working on it. But it's not a problem. We are all here critically thinking brilliant people. And we will manage to, now we have a couple of tools in our toolbox. So there is top, we showed you this one. You can try the ones that come from Slurm. And our goal is that you try this out. And let me show you, I prepared an exercise for you.
Radovan, before, what would you now set in this Slurm, in this job script?
Yes, good question. So now that I know that so I actually know that here it's 3 point something gigabyte. So what would I set in the job script? I would set, I know it's something like this. So I would set 3.5 or 4, because it doesn't matter, because every core has a little bit over 4 or a little bit below 5. So this will not give me any penalty.
If you would set it to 5, it could be that you accounted for 2 cores. If you set it below 5.
Yeah. So I like to start with a little bit less than the core has and a little bit more than I need, unless I cannot. So if I cannot, well, then I ask for more. There is also, we have high memory nodes where we have a lot more memory per core. So if I have to have a lot of memory, then I do. But the message here is that I calibrate. And now that I know...
Can we not try if it really runs? Because Slurm said 6, so it shouldn't run if Slurm was right.
Yeah, and we will see that it will actually run. So Slurm is wrong on Saga. We don't understand why yet. So we are working on it. It will complete. The real demand turns out to be 3.2 in this case.
So half of what Slurm thinks.
Yeah. So let me put here on, I just need to find it. I will put on the collaborative document the path to the exercise, and I will also show you how you can navigate through that. Let me just find the right path. The right path is, where are we? Exercises. We are here. And actually we are in choosing mem. And I don't share the screen here. Here we are. So if you're on Saga, log into Saga, go to this path, and I will go there as well. Choosing mem, not the choosing course. The choosing course is for the next session. We will go there later. In here, you find this mysterious binary where we want to find out how much it consumes. There is a run script. There is also a README file, and there is a spoiler. So look at the spoiler later, because you don't want the fun to be spoiled. Let's look at the README file. It has instructions for you. Instruction number 1, copy the example to your own home folder. Then step 2 will be submit the script, and the job will fail. And your goal is we want to train you that you can recognize the error. The error will be, well, we don't ask for enough memory. And step number 3, then you will increase the memory from 1.5 GB to 3.5. Does it still fail? A little spoiler, it will then probably work. But your goal is to take a couple of tools from our toolbox. And I recommend take this one, but also compare with some of the other tools and try to find out how much it really needs, because you will need it for your own computations. And here, I mean, apology from us, the staff, that some of the tools give actually the wrong answer since a couple of days. We don't know why. On the other clusters, this works perfectly well. And it will work soon. So it's still good to know about these tools. And before we send you into the exercise, is there anything that I didn't clarify clearly? So the expectation is, go to this. It's nicely written here. Go to this folder, have a look at README later, spoiler, and time. Let's see, 28, 15 minutes. 15 minutes. We will come back. We will summarize briefly. Maybe some questions will come up. Write the questions in the document here. And then after that, we will take a break. All right. So let's, should we, I don't know, we are not so many people. I don't know whether we should.
I have made 3 breakout rooms if people want to go into smaller rooms.
Yeah.
I will stop the recording so that people can ask questions.
Great.